Alright, so we have a polynomial function over here, or equation with the power of 2, commonly known as the quadratic equation. And we are asked to factorize this equation using the method of computation of squares. Let's go. Before I begin, let me just let you know that the general form of every quadratic equation comes in the form ax squared plus bx plus c equal to 0. Now here, if I choose to compare the coefficient, that is to compare x squared, x and the constant, obviously our a will be 2, b being 10, and our constant c being negative 8. Good. Now here, our first step is to send the constant c to the other side of the equation. That is, we will be getting 2x squared plus 10x equal to 8. Obviously, you have a negative number plus an equal to sign, get a positive number. Very good. Our next thing is to keep the coefficient of x squared as 1. How do we get that? By dividing each and every term by 2. That is divided by 2, divided by 2, and divided by 2. This then gives us x squared plus 5x equal to 4. Very good. Next, we are to find half of the coefficient of x. Then we square it. That is the power of 2. Now, taking the coefficient of x, that is 5. So find half of it, it means we are getting 1 over 2 multiplying 5, which gives us 5 over 2. And now we are to square it. So squaring this gives us 25, which is 5 squared, over 4, which is 2 squared. Good. We are to then add this 25 over 4 to both sides of the equation. It means we are getting x squared plus 5x plus 25 over 4, giving us 4 plus 25 over 4. This gives us x squared plus 5x plus 25 over 4 equal to 41 over 4. Now, with this simple expression, we want to apply a simple trick here. There is something called perfect numbers or perfect squares. I can express 25 over 4 as 5 over 2 all squared. That is, I'm getting x squared plus 5x plus 5 over 2 all squared, giving me 41 over 4. Now this can be simply written as x plus 5 over 2 all squared, giving me 41 over 4. Now let me show you how I do this trick. You could see that I was having x squared plus 5x plus 5 over 2 all squared. Simply, we take the square root of this, square root of that. I get s square cancel the square root. Good. So now after dealing with that perfect square, now we have this expression now. Now for us to eradicate this square, we then square root both sides of the equation. That is, we get the square root of x plus 5 over 2 all squared, giving us the square root of 41 over 4. We know mathematics that the square root takes care of the square root sign. This then gives us x plus 5 over 2 to be equal to root of 41 over 4. And this then gives us x to be equal to negative 5 over 2. We then have plus or minus root of 41 over 4. So you should note that anytime you take a square root of a constant number, you get a plus or minus. That's why I had a plus or minus over it. So take note of that. Very important. Good. Now note that anytime you take the square root of a constant number, you get a plus or minus of that. So be careful with that. Note that. So now I can further go on and simplify this over here. That I'll be having x to be equal to negative 5 over 2 plus or minus root of 41 over 2. Note that this root of 41 over 4 affects both the 41 and 4. So root of 41 still gives me root of 41, but root of 4 gives me 2. Then x will be equal to negative 5 over 2. I then put the first operational sign here, plus root of 41 all over 2, or I then get my x to be equal to negative 5 over 2. I then put the second operational sign, which is negative, minus root of 41 over 2. I have then factorized the expression given in the question using the method of completion of square. I hope this helped. Like this video and put in your comments. We'll then get to you. Thank you.
It's caught in the crossfire. It's caught in the crossfire.